Now the single cantilever. So what is single cantilever? Single cantilever is a beam in which one end is fixed, this end is fixed, and another end is free. Okay, so this is called as single cantilever. So we have to find out the depression, derivation for the depression. So when I apply the force, okay, so this is the force which I am applying at this point, right? When I apply force at this point, it is going to bend like this. It is going to bend like this, right? So this distance is called as the depression. So this distance we are going to find out now. So what is our aim of the derivation? The aim of the derivation is to find out this depression. So what is happening in this single cantilever is at every point there is a depression. So if I consider this point, this is a depression. If I consider this point, this is a depression. If I consider this point, this is the depression. So here we can do one thing, that we have to consider is one point over here. Let us say this is a P as a point and first we will find out this depression Y. So this is the depression Y, and this we will the beam's equation. We have to find out the equation for this, and then when we extend that, we will get the depression for this Y naught, right? So this is the idea behind this, because we will have the variables, more variables, so that we can easily integrate or differentiate the equations. So we have to take such a kind of a variables. So let us take this length of this beam is L. Length of this is L. Okay, and the distance from this to this is X. Okay, if I take distance from here, let us say this is O, from this point to this point it is X, then what is the distance here? This will be X minus L minus X. So distance from this to this is L minus X. So this is X, this is L minus X. So now this looks like a straight line, but this is not a straight line. This is a bent like this. So if I consider this is a beam, okay, and this is bent like this, this is slightly bent like this, that means at every point there is a bend. Okay, so that I can find out here what is the bending moment. So we will find that. Now what we have to consider is bending moment of a beam. Bending moment of a beam. Okay, bending moment of a beam is what? It is perpendicular distance into the force. Force into perpendicular distance. Okay, so from the previous derivation we know that the bending moment is y divided by r into ig. This is the bending moment. Y is the, where y is the Young's modulus, r is the radius of that bent curve, and ig is the geometrical inertia. Okay, so now the force, what is the force we are applying? W is the force which we are applying, that is W. And what is the perpendicular distance here? The perpendicular distance is L minus X, because we are finding the bending moment at this point. So we are finding at this point, okay, we are finding the depression at this point, so that the perpendicular distance from this point to this point is the L minus X. This is the L minus X. Okay, so we are considering this W as a force, and this is the perpendicular distance. So you may ask why we cannot consider. So this is the fixed point and this is the perpendicular distance. So why can't we consider from this point to this point? Because this is not the perpendicular distance while finding the couple or a torque, because here it is bent, so that we have to consider the distance from this point to this point. That means this is more or less equal to this point, because there is a small bend. This is almost straight line, so that we have to consider this point itself for a perpendicular distance. So this is the basic equation which we have to write down first. So bending moment is equal to this much. So let us move ahead. So here I'll take this 1 divided by r is equal to w divided by y ig L minus 6. Okay, so from the mathematics we know that 1 divided by r is equal to, it is d square y divided by dx square. Let us substitute that, so that this equation number 1 will become this is equation number 1, that is d square y divided by dx square is equal to w divided by y ig L minus x is the equation. Okay, now let us integrate this, integrating with respect to x. So what we will get, let us integrate that. So when I integrate that, so this is the integration. Okay, so that I'll get this dy divided by dx, that is equal to, okay, so that is dy divided by dx, that is equal to, so let us take out this w y ig out, integration of L minus x into dx. Okay, so this will be w divided by y ig. So what is the integration of L? L is the variable. Okay, so we can have different lengths of the beam, so that I have taken this L, and x is also variable. So these two are the variables, L and x are the variables, whereas this w y ig are constant. So this we have to integrate. So when I integrate that, this will be Lx minus x square divided by 2 is the integration of this. So this is dy divided by dx. Here again we should take the constant of integration, that is C1 I'll take as a constant of integration, right? So let us create a situation that in which if x is equal to 0, okay, then what is the value of C1? Okay, if x is equal to 0, let us put x is equal to 0. Okay, if I put x is equal to 0 here, if I substitute x is equal to 0, so this will become 0, and when x is equal to 0 here, so this will also become 0, so that therefore then C1 is equal to 0. Okay, so that this will become 0. So what is the meaning of x is equal to 0? So when x is equal to 0, so here what is the y depression? Depression will also be 0. So when x is equal to 0, this y depression will be here, so that is also 0. So that this whole equation will become 0 by giving the value of the integral constant, that is C1 is equal to 0. Okay, we have this equation now. Let us call equation number 2 and this equation 2, and again we will integrate that, integrating equation 2. Okay, what we will get by integrating this equation 2, I'll get this y is equal to, okay, now slowly we are coming towards the depression of the single cantilever. So y is equal to, so this is w divided by y ig, this is constant, and let us integrate this Lx minus x square divided by 2. So we have to integrate this with respect to, now integration of Lx is Lx square divided by 2, and integration of x square is x cube divided by 3. Already we have 2 over there. So this is the value of integration. With this we have the constant C2. So here also when I take for x is equal to 0, so when I substitute x is equal to 0, that will become 0, and y is also 0. Okay, so that therefore C2 will become 0. Right, my ultimate equation is, so depression equation is equal to w divided by y ig, this is Lx square divided by 2 minus x cube divided by 6. So this is the equation for the depression, but so still we have x over here. Okay, so still we have x over here. So what is that we have? We have this single cantilever like this. Okay, we have taken this as x, this as x, and this as L minus x we have taken. Okay, and this is the depression we have taken here like this. This is the depression, and we want this y naught. So we want this y naught. So where we are finding y, here we are finding. So at this point, this is the depression equation. At the point this p, this is the depression equation. Okay, if I extend this x is equal to L, okay, if I extend, that is x is equal to L, if I make, so this x is equal to L, if I make that, that means it will become here. So what is the depression at this point? Depression at this point is y naught. Okay, then y becomes y naught. Okay, so when I extend this, so we found this y here. Okay, y we found now. If I extend this x till here, so it will become y naught. So that therefore total depression of the cantilever is y naught is equal to, so this is y naught is equal to w divided by yig, then this L cube divided by 2 minus L cube divided by 6. Okay, we have to solve this. We need to solve this, so that this is w divided by yig. Okay, so this is 6, and here we can take this as this is 3L cube minus L cube. Okay, so that so when we solve this, we will get w y ig, this is 2L cube divided by 6. Then ultimately what I'll get is y naught is equal to w y ig, and this is L cube and 3 I'll take here. So this is the ultimate equation which we will get. So what we found is, we found this y naught. Y naught is the depression produced. In the same way we can find out this y. Y is WL cube divided by this 3 y naught Ig. I can find out this Young's modulus. Once I get Young's modulus, I can get to know what is the strength of the material. We can easily find out this y naught by experiments, and we can find out the y, that is Young's modulus of that particular material, that particular beam.